In the realm of relational databases, maintaining data integrity and consistency is paramount. Oracle Database, renowned for its robustness and reliability, relies heavily on a sophisticated mechanism known as undo data management to achieve these objectives. Undo data management is not merely a technicality. It is the bedrock upon which transactional consistency, data recovery, and read consistency are built. At its core, undo data management revolves around the concept of undo, the ability to reverse changes made to the database. This capability is essential for ensuring that transactions can be rolled back in case of errors or user intervention. Moreover, undo data plays a vital role in providing read consistency, allowing users to access a stable view of the database even while other transactions are making modifications. Without effective undo data management, the integrity of the database would be compromised, leading to data corruption, inconsistencies, and ultimately, an erosion of trust in the system. Imagine a scenario where a transaction modifies a record, but due to an error, the transaction fails. Without undo data, the database would be left in an inconsistent state, potentially jeopardizing the accuracy of subsequent operations. In essence, undo data management is the unsung hero of database operations, working tirelessly behind the scenes to ensure data integrity, consistency, and reliability. In the following sections, we will delve deeper into the intricacies of undo data management in Oracle Database, exploring its components, benefits, and best practices for optimal performance. At the heart of Oracle's undo data management lies the concept of undo segments. These specialized storage structures serve as repositories for undo data, capturing the before image of data blocks that have been modified by transactions. When a transaction alters data within a database block, the original state of that block is preserved as undo data within an undo segment. Undo segments are organized within undo table spaces, dedicated storage areas allocated specifically for undo data. Each undo table space can contain multiple undo segments, and each segment is associated with a specific transaction table. This segregation ensures that undo data is managed efficiently and that the undo operations of one transaction do not interfere with others. The lifecycle of an undo segment is closely tied to the transactions it serves. When a transaction begins, it is assigned to an undo segment. As the transaction modifies data, the corresponding undo information is recorded within that segment. If the transaction is committed, the undo data is retained for a period to support read consistency and potential rollback operations. However, if the transaction is rolled back, the undo data is used to revert the changes made to the database, effectively undoing the transaction's effects. A read consistency is a fundamental principle in database management, ensuring that users access a consistent view of data even while other transactions are making modifications. Oracle Database achieves read consistency through the ingenious use of undo data. When a transaction begins, it establishes a read-consistent view of the database based on a specific point in time, known as a system change number, SCN. As other transactions commit changes, the database's SCN advances. However, a transaction's read-consistent view remains anchored to its initial SCN. When a transaction attempts to read data that has been modified by a committed transaction with a higher SCN, Oracle Database utilizes undo data to reconstruct the before image of the data, effectively presenting the data as it existed at the transaction's initial SCN. This mechanism ensures that users perceive a stable and consistent database state, shielded from the ongoing flux of modifications. It prevents phenomena such as dirty reads, where a transaction reads data that has been modified but not yet committed by another transaction, potentially leading to inconsistencies. Read consistency is crucial for maintaining data integrity and accuracy, preventing anomalies and ensuring that users can rely on the information retrieved from the database. Without this mechanism, the database would resemble a constantly shifting landscape, making it difficult to guarantee the correctness of data retrieval operations. Prior to Oracle 9i, managing undo data was a manual and often complex task, requiring administrators to carefully size and allocate undo segments. However, with the advent of automatic undo management, this process has been streamlined and automated, relieving administrators of the burden of manual undo management. Automatic undo management introduces the concept of the undo table space, a dedicated storage area for undo data. Instead of manually creating and managing individual undo segments, administrators simply create an undo table space, and Oracle Database automatically handles the allocation and management of undo segments within that table space. The system monitors undo space usage and dynamically adjusts the size of undo segments as needed. When a transaction requires undo space, Oracle Database automatically allocates an appropriate amount of space within the undo table space. This dynamic allocation ensures that undo space is efficiently utilized, preventing both shortages and overallocation. Automatic undo management simplifies undo data management, reducing administrative overhead and ensuring that undo space is effectively allocated and utilized. This automation frees up administrators to focus on other critical tasks, such as performance tuning and database optimization. The undo table space is a specialized storage structure dedicated solely to housing undo data. It serves as the central repository for all undo information generated by transactions within the database. Unlike other table spaces that store user data or temporary segments, the undo table space is exclusively reserved for undo management. When automatic undo management is enabled, the system automatically creates and manages undo segments within the designated undo table space. These segments are dynamically allocated and deallocated based on the undo space requirements of active transactions. The undo table space acts as a buffer, absorbing the ebb and flow of undo data as transactions modify data within the database. The size of the undo table space is a critical consideration, as it determines the amount of undo data that can be retained. If the undo table space is too small, it may lead to snapshot too old errors, indicating that the system cannot provide read consistency due to insufficient undo data. Conversely, an excessively large undo table space can waste valuable storage space. Proper sizing of the undo table space is essential for optimal database performance and read consistency. By providing an adequate repository for undo data, the undo table space ensures that the system can maintain data integrity and provide consistent data views to users. Automatic undo management brings forth a multitude of benefits, enhancing both efficiency and performance in Oracle Database. By automating the intricacies of undo data management, this feature streamlines operations, reduces administrative overhead, and optimizes resource utilization. One of the primary advantages of automatic undo management is its ability to dynamically allocate and deallocate undo space. The system continuously monitors undo space usage and adjusts the size of undo segments as needed, ensuring that adequate space is available for ongoing transactions. This dynamic allocation prevents both undo space shortages, which can stall transactions, and overallocation, which can waste valuable storage resources. Moreover, automatic undo management simplifies the management of undo data. Administrators are relieved from the burden of manually sizing and allocating undo segments, freeing up their time for other critical tasks. This automation reduces the potential for human error and ensures that undo space is managed efficiently. Furthermore, automatic undo management enhances database performance by optimizing undo operations. The system's ability to efficiently allocate and deallocate undo space, combined with its streamlined management, minimizes the overhead associated with undo data management. This results in faster transaction processing and improved overall database responsiveness. Implementing automatic undo management in Oracle Database is a straightforward process involving a few key steps to enable this powerful feature and reap its benefits. The process begins with creating an undo table space, the foundation for automatic undo data management. To create an undo table space, you would use the create undo table space statement, specifying the desired name and storage parameters for the table space. For instance, SQL create undo table space undo tbs1 data file /u01/app/oracle/oradata/db1/und/tb01. dbf size 100 M. Once the undo table space is created, you need to assign it to the database instance. This is achieved by modifying the database initialization parameter, undo_table space, to point to the newly created undo table space. For example, SQL alter system set undo _table space undo tbs1 scope both. After setting the undo_table space parameter, you need to restart the database instance for the changes to take effect. Upon restarting, Oracle Database will automatically begin using the designated undo tablespace for managing undo data. With these steps completed, automatic undo management will be fully enabled, streamlining undo data operations, enhancing efficiency, and optimizing database performance. While automatic undo management automates many aspects of undo data management, monitoring and tuning remain crucial for ensuring optimal database performance. By keeping a watchful eye on undo-related metrics and making necessary adjustments, administrators can fine-tune the system for efficiency and responsiveness. One of the key metrics to monitor is the undo tablespace usage. Oracle Database provides various tools and views to track undo space consumption, allowing administrators to identify potential bottlenecks or overallocation. If the undo tablespace consistently approaches its capacity, it may indicate the need to increase its size to accommodate the workload. Another important aspect to monitor is the rate of undo generation. Excessive undo generation can strain system resources, leading to performance degradation. Analyzing undo generation patterns can reveal areas where application code or database configurations can be optimized to reduce undo overhead. Tuning undo retention is also crucial for striking a balance between read consistency and undo space consumption. The undo_retention parameter determines the minimum amount of time that undo data must be retained. While a longer retention period enhances read consistency, it also increases undo space requirements. By diligently monitoring and tuning undo management, administrators can ensure that the system operates efficiently, providing optimal performance and maintaining data integrity. To maximize the effectiveness of undo data management in Oracle Database, adhering to best practices is essential. These practices encompass various aspects of undo management, from undo tablespace sizing to application code optimization. One of the fundamental best practices is to adequately size the undo tablespace. A properly sized undo tablespace ensures sufficient space for undo data, preventing snapshot too old errors and accommodating the workload's undo requirements. Monitoring undo tablespace usage and adjusting its size as needed is crucial for maintaining optimal performance. Another crucial best practice is to minimize undo generation. Excessive undo generation can strain system resources and impact performance. Analyzing undo generation patterns and identifying areas where application code or database configurations can be optimized to reduce undo overhead is essential for efficient undo management. Furthermore, optimizing undo retention is crucial for striking a balance between read consistency and undo space consumption. Setting the undo_retention parameter appropriately ensures that undo data is retained for a sufficient period to support read consistency without unnecessarily consuming undo space. By embracing these best practices, administrators can enhance undo data management, optimize database performance, and ensure data integrity and consistency. In the realm of Oracle Database, mastering undo management is paramount for achieving optimal performance, ensuring data integrity, and maintaining read consistency. Undo data management, often operating behind the scenes, plays a pivotal role in supporting transactional consistency, data recovery, and a stable database view for users. From the foundational concept of undo segments to the automation provided by automatic undo management, understanding the intricacies of undo data management is essential for database administrators and developers alike. By grasping the significance of undo tablespaces, monitoring key metrics, and adhering to best practices, one can harness the power of undo management to enhance database efficiency and reliability. As we conclude this exploration of undo data management, remember that it is not merely a technicality, but a cornerstone of robust and reliable database operations. By mastering undo management, we unlock the full potential of Oracle Database, ensuring data integrity, consistency, and optimal performance for all who rely on its power.